ので、これよりセッションを開始します。それでは、谷口さんによる Scala to WebAssembly 同期投法のです。どうぞよろしくお願いします。
Oh, all right. Hi everybody. Welcome to Scala to WebAssembly How and Why. My name is Rikito Taniguchi. I'm a Scala compiler engineer at Vertestrap, a company behind the Scala compiler and tooling development. I am here to talk about the WebAssembly support in Scala because, WebAssembly support for Scala is coming. So as you can see, we support WASM as part of Scala.js, and you will be able to generate WASM instead of JavaScript using Scala.js in future. So in this talk, I'm gonna talk about the what is WebAssembly and I'm gonna talk about the current WASM support status, and then I'm gonna talk about why I think WASM is important for Scala and how we support WASM in Scala. So I'm gonna wrap up with the future plan of the WASM support in Scala. So as you can see, unfortunately, I don't have a demo in this talk because once there's not enough time, and the second reason is I couldn't come up with a flashy demo for WASM, because what we can do with Scala WASM is the same as what we can do with Scala.js. So if you want to see the running example, please come and talk to me after this talk. So anyway, let's begin with what is WebAssembly. Please raise your hand if you have ever been heard about what is WebAssembly. Oh, that's many. Then please raise your hand if you have ever played around with WASM. Not so many. Okay, don't worry because I'm gonna start with what is a WebAssembly. So by its standard definition, WebAssembly is a binary instruction format for a stack-based virtual machine. WASM has a distinguished features. For example, WebAssembly is designed to be fast startup and execution. Since WASM is a binary format, decoding WASM binary is much faster than parsing JavaScript. And also WASM is designed to be decode, validate, compile in stream or in parallel. So WASM startup time is really, really fast. Also, another notable feature in WebAssembly is that it's designed to be safe because it runs in a sandboxed environment. So you can run the untrusted third-party or user-written code in a safe WASM environment. So another interesting design of WASM is it's a polyglot and portable. WASM specification is not tied to any specific programming languages. Actually, many programming languages like Scala, C, Go, Rust, and Kotlin or OCaml can be compiled to WASM. And moreover, WebAssembly is designed to be portable, which means it can run on any hardware or platform, like from desktop devices to mobile or IoT devices on any architecture or any operating systems. So in summary, WebAssembly is fast, secure, polyglot, and portable binary formats that runs on browsers and other platforms. Okay, so let's move on to the current WASM support in Scala. We support WASM as part of Scala.js. For those who are not familiar with Scala.js, Scala.js is a dialect of Scala targeting JavaScript platform. Scala.js front-end compiles the Scala program into a Scala.js IR, Scala.js intermediate representation called SJS IR, and Scala.js backend compiles the SJS IR into JavaScript. So the WASM support is in Scala.js is implemented as another backend for Scala.js. So it's going to take SJS IR and it generates WebAssembly instead of JavaScript. Current WASM's backend of Scala.js generates some JavaScript helper functions in addition to WASM binary. So we can use Scala.js generated WASM in JS runtimes such as browsers or Node.js and Dino, but it cannot be, it isn't yet supported in standalone WASM runtime such as WASM time or WASM Edge, which is important for server-side WASM. So in summary, current WASM support makes Scala.js fast startup time, and it's gonna be a fast execution. Actually, it depends on the application's future, and also the WASM provides a small code size, and WASM also provides a sandbox environment. So yeah, that sounds good, but is that all that because I'm so excited about WASM? Actually, no. WASM's potential is much more than these features. So next, I'm gonna talk about why I think WASM is so exciting for Scala developers in future. I said in future because the three things I'm gonna talk about is not yet supported in the current WASM support in Scala, but I believe those things gonna expand the Scala's capability in future. So three things is WASM beyond the browser, WASM component model, and it's WASM's evolving landscape. First, WASM is going beyond browser. As you may know, WASM was originally designed for browsers, but it is now used in various environments outside browsers. For example, WASM is great fit for serverless applications because of its fast startup time, and containers and WebAssembly is surprisingly work well together due to WASM's portability and its sandboxing feature, and also, WASM has less abstraction layers than current Linux containers. So, and also WASM is also a good option for plugin or extensions because we can safely run user-written untrusted code safely on WASM thanks to its sandboxing. Actually, VS Code or Envoy, we can write a plugin for VS Code or Envoy, and we can write a UDF in TIDB. So yeah, WASM's fast execution, startup time, and sandboxing and portability are variable in various environments, not only in the browser. In those environments, JavaScript is not necessarily involved. Instead, those WASM module access to the system resources using the standardized API called WASI. WASI stands for WebAssembly System Interface. That provides a standardized typed interface for host system resources. I don't talk about the details because we don't have so much time, but thanks to WASI, we can access to system resources while maintaining the WASM's portability, and we can use the WASMs outside the browsers. So next thing I'm so excited about WASM is a WebAssembly component model proposal. WebAssembly, a WebAssembly module may import functions from the host runtime and export such items to the host. However, there is no standardized way to directly communicate between modules, and the types we can use in the interfaces of the export and import is quite limited. Like only we can use I32, I64, F32, and F64. And there is no standardized way to serialize high-level types such as strings or recalls or whatever. So it's going to be a problem. That means we cannot share the WASM modules in a portable way. For example, maybe the string representation in Scala and string representation in Rust is different, so we cannot reuse the WASM modules between Scala and Rust, or any different languages. So WASM component model proposal specifies a standardized way to directly communicate between different WASM components. So they define a standardized way to serialize and communicate high-level types such as string, record, enum, list, result types. And it makes possible to directly communicate between WASM components built from different languages like Scala or Kotlin or Rust or any other languages. So WASM component model has a potential to to make any programming languages to directly communicate with any other programming languages. So last thing is that WebAssembly is evolving. The WebAssembly is continuously discussing about the new features or toolings. So I don't talk about the details, but there are proposal to add SIMD instruction to WASM, or it's also talking about the stack switching proposal, which is important for supporting the green threads in WASM. Okay, so now let's move on to how we support WebAssembly in Scala. Interestingly, WASM support was already considered back in 2019. This is a presentation in the Scala Days 2019 at Lausanne by Sebastian, who is the author of Scala.js. However, the garbage collection, native garbage collection was not supported by WASM in 2019. And without WASM native garbage collection support, we would have a problem with interoperability between JavaScript and WebAssembly. So that's why we didn't work on WASM support in 2019. Like, for example, like to compile Scala to WebAssembly in 2019 without native WASM ZC, there are basically two options. One way is that compiling the JVM itself to WASM, like running the Java bytecode on JVM, which runs on the WASM. So we can support WASM in the JVM languages. Actually, there is a product called JPJ, which is a JVM that runs on WASM. But as you can imagine, there's a problem like the binary size gonna be really huge because the WASM binary contains the JVM. So it's good for like porting the legacy Java application for browser environment, but it's not good for enjoying the fast startup and execution in WASM. And another way around is embedding our own garbage collection code into our WASM modules. However, I don't explain the details, but it also has some problems with runtime performance and the interoperability between JavaScript and WebAssembly. It's called a cycle collection problem. If you are interested in that, please come to me after this talk. But in 2024, it's 5 years past, and in 2024, there is a solution. WASM native garbage collection called WASM ZC is supported by many runtimes. This proposal provides GC managed data structures and instructions built into the WASM spec. And those data types will be GC managed by the WASM runtime. So WASM ZC allows ZC languages like Kotlin, Java, OCaml, and Dart, and Scala to be directly compiled to WASM without needing to embed our own garbage collectors to or compile the JVM to WASM. 5 years ago, WASM ZC was in very early stage, but now as I mentioned, the number of WASM runtimes support WASM ZC. For example, this includes JavaScript engines such as V8, SpiderMonkey, and JavaScript Core. Also, standalone WASM VMs such as WASM Edge 0.14 supported WASM ZC, and WASM Time and WASM Micro Runtime is also working on supporting WASM ZC. So that's why 2024 is right time to working on WASM support in Scala using WASM ZC. So yeah, that's how we finally started working on WASM in Scala using WASM ZC. And yeah, here's a pull request. It's not yet merged, but I hope it's gonna be merged in the near future, and we can enjoy the WASM in Scala. So I'm gonna wrap up with the future plans of Scala support in WASM support in Scala. So as I mentioned, current Scala WASM support doesn't work in a standalone WASM, which is important for server-side WASM. So we are planning to support those standalone WASM by get rid of JS interoperation semantics, supporting WASI, and re-implementing the JS dependent libraries. And also, we are planning to support WASM component model that requires new interoperability semantics between different languages. Also, we should be able to further optimization on our WASM binary using Scala.js optimizer and WASM opt, which is WASM's optimizer. So, okay, this is the end of the presentation. I believe WASM will bring Scala to a new horizon or a new ecosystem. So with server-side WASM or WASM component model. And if you are interested in WASM support in Scala, please test it out once it's released. And if you wanna hear more about WASM in Scala, please come to me after this talk. And so that's it. So thank you for your attention, and please enjoy the rest of your Scala Matsuri. So.
谷口さん、発表ありがとうございました。それでは質疑応答に移ります。質問がある方は挙手でお願いします。質問ありませんでしょうか。あ、そう。
Thank you very much for the presentation. Very interesting. Is there any reason why you decided to go with the Scala.js route instead of Scala native? Can you maybe talk a bit about it, please?
Yeah, that's a great question. Actually, I prepared a slide for that. So yeah, it's a great question because, for those who are not familiar with Scala native is another Scala dialect that targeting the LLVM, native binary using the LLVM. And LLVM supports WASM, so it makes sense that people wonder why we use the Scala.js instead of Scala native, because we can just use the LLVM to generate WASM. Yeah, there's some good reason to use Scala native. One is we can rely on LLVM and mscripten, which is WASM compiler for LLVM. So we can generate WASM out of the box from Scala native. And so Scala native libraries should work out of the box. So they are good reason to use Scala native for WASM. But however, the problem is LLVM doesn't support WASM ZC. So this is a huge problem because we need to embed garbage collection code to WASM modules, and that's gonna be a problem. For example, supporting the garbage collection in WASM module is really expensive for some reason because WASM cannot access to its stack. So we have to have something called shadow stack, which is manipulated with WASM's stack. So it's so expensive. And another reason is it's too complicated to talk here, but GC, it's gonna have a serious problem with the JavaScript interpretability with WebAssembly. So that's why we believe WASM-ZC is really important for Scala to support WASM. And so yeah, that's why we didn't pick up Scala native.
ありがとうございます。もう一人、じゃあどうぞ。
Thanks for the talk. How about the integration of this feature? Will it be integrated in the SBT plugin for Scala.js as well? Like, for example, fast link.js, I think it's called, and there will just be a new keyword, or how's the plan on that?
Yeah, that's a good question. It's gonna be WASM support gonna be provided in the one option in Scala.js. So if you set for example, use WASM option in Scala.js, you're gonna generate a WASM instead of JavaScript. So it's gonna be supported in any build tools like a SBT or Mule or anything.
Cool, thank you. And what about the Scala version itself? Is it available from 2.13 onwards or only 3?
Yeah, I believe so. Yeah.
Thank you.
ありがとうございます。では、時間が来ましたので、こちらのセッションを終わらせていただきます。谷口さん、ありがとうございました。
ありがとうございます。Thank you very much.